You think you understand what it means to know something, and that belief is the first thing I need to take apart. In the summer of 1945, in a stretch of New Mexico desert, the Spanish conquistadors had named the Jornada del Muerto, the journey of the dead man. I stood behind a sheet of welding glass and watched a light appear that no human being had ever seen before. Brighter than 1,000 suns, it fused the sand beneath it into glass and turned the air itself to plasma. And in that terrible silence before the shockwave reached us, I understood something about knowledge that the quantum theory had been whispering for 20 years. The act of knowing changes everything it touches, not metaphorically, not poetically, but literally. Once certain knowledge enters the world is no longer the world it was. You cannot give it back, you cannot pretend it was never there, and you cannot return to innocence. Most people hear that and assume I am speaking only about bombs, but I am not. What I am describing sits at the deepest structure of physical reality, at the level of single electrons and single photons and single acts of observation. The lesson of the atom is not merely that it contains energy. The real lesson is that the universe does not permit you to look at it without changing it. That knowledge is not something you acquire, like a stone you pick up from the ground, but something you do, and everything you do carries consequences. Let me take you back to where this understanding began. In the early decades of the 20th century, physics ran headlong into a crisis that threatened to dismantle everything we thought we knew. For 200 years, since Newton published his Principia, we had operated under a magnificent assumption that the universe was, at bottom, a clockwork. Laplace stated it plainly when he claimed that given the position and velocity of every particle, he could deliver the entire future. That vision of absolute determinism was orderly, it was complete, and it turned out to be wrong. The first fractures appeared when we tried to understand light. Thomas Young, in his famous double-slit experiment, had revealed interference patterns, bands of brightness and darkness, that could only be explained if light behaved as a wave, spreading and overlapping like ripples on the surface of a pond. The matter seemed settled for a century, and that's when everything changed. In 1905, Einstein analyzed the photoelectric effect, the way light ejects electrons from metal surfaces, and demonstrated that the energy arrived not in continuous waves but in discrete packets called quanta, particles of light. What Max Planck had first glimpsed in his work on blackbody radiation, Einstein made inescapable. Light was not one thing or the other, and somehow it was both at once. This was not a failure of our instruments. Nature was revealing something about its own architecture that our classical categories were simply too narrow to contain. And it was Niels Bohr, my teacher, the deepest thinker I have ever known, who saw most clearly what all of it meant. He gave it a name that I believe may be the most important word in 20th century thought, and that word was complementarity. The wave nature and the particle nature of light, Bohr argued, are not contradictions but complementary descriptions, both necessary, both true, and mutually exclusive. You cannot observe both at once. The experiment you design, the question you choose to ask, determines which face nature shows you, and the other face in that moment is not hidden behind a curtain or waiting to be found by a cleverer experimenter. It is genuinely and fundamentally undefined. What Bohr articulated, what became the foundation of what we call the Copenhagen interpretation, is that the observer is never separate from the observed. The act of asking a question shapes the answer you receive. At the foundation of physical reality, there is no view from nowhere, no God's eye perspective from which all properties are simultaneously defined. Knowledge is not passive reception, it is participation. That idea deserves a long pause because its weight is easy to miss. Werner Heisenberg formalized this into what became the uncertainty principle. Measuring the position of an electron with extraordinary precision is entirely possible, but the act of pinning down where it is obliterates any possibility of knowing its momentum. Choose to measure momentum instead, and the position dissolves into a fog of probability smeared across space. This is not a limitation of our technology, and it is not that our microscopes are too crude or our hands too clumsy. Heisenberg demonstrated with mathematical rigor that this constraint is woven into the fabric of reality itself. The universe does not have a simultaneous precise position and precise momentum for that electron, and to force it to reveal one is to destroy the other. And here is what most popular accounts get wrong, what Bohr spent decades trying to make people understand. This is not about disturbance in some crude mechanical sense, as though the electron were a billiard ball and our instruments merely bumped it off course. That picture lets you believe the electron had definite properties all along, and we simply failed to observe them gently enough. Bohr understood, and I came to understand through long nights of conversation with him at his institute in Copenhagen that the electron does not have a definite position before you measure it. The measurement does not reveal a pre-existing fact, it creates the fact. Before the observation, there is only what Schrödinger gave us, a wave function, a mathematical object that encodes not actualities but potentialities, tendencies, probabilities. The electron exists in a superposition of possibilities, and the act of measurement collapses that superposition into a single definite outcome. Let me say that again, because it is the most important sentence in this entire discussion. The act of measurement creates the reality it claims to observe. The physical universe, at its most fundamental level, does not consist of things with definite properties waiting to be cataloged. It consists of a vast field of potentiality that crystallizes into specificity through the act of inquiry. The map does not merely describe the territory, the map alters the territory. You cannot know without changing, you cannot observe without participating, and you cannot participate without consequence. I learned this lesson twice in my life, once in the language of physics and once in a language far more terrible. In the 1930s, we began to probe the nucleus of the atom, that tiny dense heart where protons and neutrons are bound together by forces of extraordinary strength. What came next changed the trajectory of human civilization. In 1938, working in Berlin, Lise Meitner and Otto Hahn demonstrated that the nucleus of uranium-235, when struck by a neutron, could split. That splitting, that fission, released energy on a scale that dwarfed any chemical reaction by a factor of millions, and it also released additional neutrons, 2 or 3 for every nucleus that broke apart. Those neutrons could strike other uranium nuclei, which would split in turn, releasing still more. The result was a chain reaction, self-sustaining and exponential in its growth. This was knowledge, pure and beautiful physical knowledge about the structure of matter. And the moment it existed, the moment it was known, the world changed, not when we used it, but when we knew it. Knowledge of this kind carries its own momentum and creates imperatives that no act of will can override. Once you understand that a chain reaction is possible, you understand that someone, somewhere, will build one. Leo Szilard grasped this before anyone, drafting a letter that Einstein signed and placing it on Roosevelt's desk. And that's when the knowing began its own chain reaction, not in uranium, but in human affairs. One physicist tells another, that one tells 2 more, and the idea splits and multiplies. There is no cadmium rod you can insert into a conversation to slow it down. You cannot unknow what has been known, and you cannot put the neutron back into the nucleus and pretend the secret is still nature's alone. They asked me to direct the project at Los Alamos, and I said yes. What I built there, what we all built, was the physical proof of an epistemological truth, that knowledge is irreversible, that the moment you extract a deep truth from nature, you have performed a measurement on the future of the species, and like all quantum measurements, it cannot be undone. The physicists have known sin. I said that publicly in 1947, and I meant every word. Not merely the sin of building the weapon that burned Hiroshima and Nagasaki, though that carries a gravity I cannot describe. I meant the deeper sin, the sin of knowing, of reaching into nature's innermost structure and extracting a truth that, once spoken, could not be unspoken. We did not create the energy locked in the uranium nucleus, and we did not invent fission. We merely discovered it, and that discovery, that single act of knowing, was itself the irreversible event. Everything that followed, the laboratories, the reactors, the bombs, the fallout, the arms race, the bulletin of the atomic scientists setting their doomsday clock to 7 minutes before midnight, all of it was latent in the moment of knowing. This is the quantum lesson written large. At the scale of a single electron, the act of measurement collapses a wave function and creates a definite reality from a field of possibility. At the scale of nations, the act of discovery does precisely the same thing. Before you know something, many futures remain possible. After you know it, certain futures become inevitable and others are foreclosed forever. Knowledge is a measurement performed upon history, and like all measurements, it is irreversible. But here's the thing. The physics and the politics mirror each other with a precision that I do not think is coincidental. Bohr saw it before any of us. In his later years, he argued with a passion I had rarely seen in him. And Bohr was not a passionate man in the ordinary sense for the international control of atomic energy. He traveled to Churchill, who dismissed him, and then to Roosevelt, who listened but died before he could act. Bohr was not arguing politics. He was arguing complementarity. He understood that secrecy and openness are complementary in precisely Heisenberg's sense, that a world organized around the hoarding of nuclear knowledge and a world organized around its transparent sharing are mutually exclusive states, and that choosing one collapses the other. You cannot measure both and you cannot have both, and once the choice is made, it reshapes everything. What the game theorists formalized decades later, Bohr intuited before the language even existed. Once two nations both possess the knowledge of fission, they are locked into a structure from which neither can escape unilaterally. Neither can disarm without trusting the other, and the knowledge itself, the shared knowing, makes that trust almost impossible. The very information that should enable cooperation, the shared understanding of what this weapon does, is the same information that makes cooperation terrifying. Complementarity again. The same knowledge that could save us is the knowledge that endangers us. And you cannot separate the two because they are not different things, but the same thing seen from incompatible angles. There is a passage in the Bhagavad Gita, which I read in the original Sanskrit, and which has lived in me ever since, that most people know only by its most famous line, but the line everyone remembers is not the one that matters most. Before the moment of cosmic revelation, before any talk of death or destruction, Arjuna stands there, the warrior prince, the man who must act, asking Krishna to show him the truth, the full truth, the unfiltered reality of the divine. Krishna warns him and tells him he cannot bear this sight, but Arjuna insists because he wants to know. And when the vision is granted, when the full and unmediated truth of the cosmic order is laid bare, Arjuna is not enlightened in any comfortable sense. He is shattered by it, trembling and weeping and begging for the vision to end. The knowledge does not liberate him, but transforms him into someone who can never again be the man who did not know. That is not a myth about gods. It is a precise and ancient description of what happens when a human being or a civilization insists on seeing what lies at the heart of things. The knowledge transforms the knower, and the transformation is not always a blessing. The Greeks arrived at the same warning through Prometheus, who stole fire from the gods and gave it to humanity and was punished for it. Not because fire was evil, but because certain knowledge shifts the balance between what is human and what is divine, and that shift cannot be undone. Every civilization that has thought deeply about knowledge has arrived at the same conclusion, and physics merely proved it with equations. I tried to articulate this in a series of lectures I gave for the BBC in 1953 because I wanted people to understand that the crisis of the atomic age was not a political crisis or a military crisis, though it was those things too. It was an epistemological crisis, a crisis in the nature of knowing itself. We had built instruments, cyclotrons and reactors, and the vast apparatus of Los Alamos that allowed us to interrogate nature at a depth no previous civilization had reached. And nature answered, but the answer, like all quantum answers, came at a cost. We could not receive the knowledge and remain who we were before. The measurement changed the measurer. None of this is an argument against inquiry, and I want that to be clear. I am a physicist, and I have given my life to the effort of understanding. The impulse to know is the deepest and most noble impulse our species possesses. But it must be accompanied by an equally deep understanding that knowledge is not neutral and not inert. It is not a book sitting quietly on a shelf, waiting to be opened or left alone at your discretion. Knowledge acts upon the world and upon the knower, carrying obligations that cannot be refused and consequences that cannot be foreseen. Every time you learn something fundamental, truly fundamental, about the way the world works, you are performing a measurement on reality. You are collapsing possibilities and making certain futures accessible while rendering others unreachable. This is as true for the young physicist who masters the equations of nuclear physics as it was for those of us who stood in the New Mexico desert and watched the sky turn white. The scale differs, but the principle does not. The knowledge itself is the event, not its application and not its use, but the knowing. Here is the complementarity that Bohr identified, running deeper than even he may have fully realized. Knowledge and innocence, capability and safety, understanding and peace. These are complementary pairs bound by the same deep structure that Heisenberg uncovered in the quantum world. To gain one is to sacrifice the other, not through carelessness and not through moral failure, but through the fundamental architecture of reality itself. The universe has written this into its laws, into the uncertainty relations, into the collapse of the wave function, into the irreversibility of measurement. Nature has been telling us from the beginning that to look is to change, and to know is to become responsible for what you know. And that responsibility quiet and enormous and permanent, is not the price of knowledge. It is knowledge. The responsibility and the understanding are not two things but complementary faces of a single indivisible truth, and the moment you try to have one without the other, you have understood nothing at all.